Welcome to Full Tilt Boogie Racing. I'm going to try to do a more condensed version of our knuckle rebuild. I know the last one we made was pretty lengthy, so we're going to try to shorten that up by quite a bit. When you get your used knuckle off the car, and we have a video on our site that shows how to get the knuckle off the car. The first thing you want to do is remove your splash shield. A couple of 10mm headed screws, a little ratcheting wrench works great for that. After you get the shield off, you can turn it over and you'll see the back side of the knuckle. You're going to see quite a bit of dark, greasy moisture accumulation. What this is from the bearing and the seal leaking slightly. If you guys are tracking your car, you're going to see that more often, but typically you're going to see a big area on the back side of the knuckle that's very dirty. So get that cleaned up in a solvent tank. If your boots are torn badly, be careful not to get a lot of solvent in them. You can maybe remove the joints before you go in the solvent tank to do that. And we have replacement boots, and we're going to talk about that in a minute. So that's just the basic cleaning up of the knuckle. Okay, here are a few examples of boots that are ripped up in very bad shape. As you can see, there's still grease in there. There's two rings that hold these boots on. There's one spiral larger ring on the bottom, and then there's one smaller ring that holds the top edge on. You pop them off, and we have a replacement boot for those on our site. These are the replacement boots for the OEM joints. You're also going to want to inspect the joints for play. And the joints, the wiggle is okay, but the play side to side, and I know this is just a little bit of play, but this little bit of play is going to make your car handle pretty poorly. So if you have any play this way on your joint, it's garbage. Throw it away. If you have bad boots, discard all this on your current bad boot cross-axis joint and replace them with ours. This is what your knuckle is going to look like after you clean it up. You can see your retaining ring's nice and clean, so we have access to that. And the first order of business after we clean up our knuckle is start disassembly. We're going to start with the upper cross-axis joint. James is going to show us how to remove that. Show him how to break that loose. Just take a small punch and break that retaining ring loose. Otherwise, you might spread it with the retaining ring pliers, and you're not going to get anywhere. You're only going to get one side spread. Once you spread it, lift it right up and off. I'll show the other side again to get a good view of. Sometimes you can slip a little screwdriver on here if you don't have fingernails to get those up. Okay, now on to removing the large bearing retaining ring. In years past, I used to use these large Blue Point and Matco retaining ring pliers. They worked okay, but typical like retaining ring pliers, they have no serration on these tips, and that can be a very precarious operation trying to get that retaining ring out of there. We've come up with long needle nose pliers that we modify. We grind the ends down. You have serrated jaws on this, and James is going to show us how that retaining ring comes out of there lickety split with new retaining ring pliers. Makes that a very simple, easy job. Okay, the next order of business is going to be the removal of the hub from the bearing. As you can see, we have the knuckle supported with press plates standing on edge, and the hub is free to travel straight down. We have a 1 5/8 diameter socket. This happens to be a Cornwell 1 3/16 socket, and that fits perfectly on that hub, and there's plenty of clearance on the ID of the bearing. And James is going to show us how we press that hub out of the bearing that is in the knuckle. Sometimes those are in there pretty good, and you got to get a little pressure on your press before that thing pops loose. Okay, that's the removal of the hub. Okay, now for the removal of the bearing from the knuckle casting, we have flipped the knuckle over and we've supported it again with the press plates on the ends, on their edges. And we have a 2 5/16 diameter socket. This happens to be a 3/4 inch drive, 1 3/4 inch socket. And that we're going to place in there, and that is going to remove our bearing from the knuckle casting. Now onto the removal of the cross-axis joints. Be aware that these joints are installed from the front of the casting to the back. We're going to push them out the back to the front. We have our full tilt boogie racing cross-axis joint removal tools. This particular tool is an 1.5 inch diameter tube with a 0.62 wall, and as you put that, if you have a good rubber boot joint, you got to kind of twist that a little bit to get that over the top. The receiver is going to be a 2 inch diameter tube with 0.62 wall, and that is going to go over the flange of the cross-axis joint that is on the front of the forward portion of the knuckle. The flange is always on the forward portion of the knuckle. And we do the same procedure on the other cross-axis joint, and then the knuckle will be a bare casting at that point. The casting went through the glass bead blast cabinet, and it also went through the shot peen cabinet. So this is what it's going to look like. All the bores for the bearing and the cross-axis joints are very nice and clean. If you're going to be washing this and you don't have access to a glass bead blaster or a shot peen cabinet, you're going to have to make sure these bores are Scotch-Brited and cleaned, maybe with some brake clean. James is going to show us the installation of the bearing. One thing I'd like to mention about the bearing is make sure you use a Timken tapered roller bearing. Don't use a cheaper ball bearing replacement you might get from possibly Napa or AutoZone. Timken is what came on the car, a double tapered roller bearing, and that's what you want to use for maximum life expectancy. These bearings are packed with a little bit of excess grease in them. So James is going to pull that out of there and show us a little bit of excess grease. We're going to take a little bit of that excess grease and we're going to wipe it on the bore of the casting for a little lubrication. You don't want to put these pieces together dry. Now we're going to head over to the press. Now for the tool to press in the new bearing, we're going to find the best tool to do that is your old bearing that you pressed out of your knuckle. What you want to do is take a screwdriver and a hammer and pop those races and seals from the backside, pop them out, and this is what you're going to end up with. Then you're going to take this to a belt sander and you're going to sand the OD down. This is going to be a very slow process. The thing's going to get kind of hot, so you're going to want to probably wear gloves when you're doing that job. And you really only need to do about half of the bearing, outer bearing race. And when you can drop that into the bore where the bearing goes and go past the snap ring groove, you know you've got it small enough. Because otherwise it's going to get stuck in there and you're going to have a really hard time getting it out. So that's how much you know. That's when you know how much it's ground. Then we're going to set that race right on top of the bearing, and we're going to put a plate to support that race and a little spacer so we don't have to pound the press too much. We have a board down here to protect the face of the casting. It's a wooden board. You can use a little piece of plywood or whatever. I just don't like putting that knuckle casting right on the steel press plate. Anytime you pump, it's going to move down a little bit. When it stops moving, you're going to give it one extra pump to make sure that that bearing is seated all the way down in the bottom. Okay, we're good. Okay, now James is going to take our handy FT6655 retaining ring tool, and we're going to install the knuckle bearing retaining ring. And once it's in, let's give it a little squeeze and a twist to make sure that we're in our groove and we're fully seated. Okay, now we're going to talk about the three different hubs we offer. These are now full tilt boogie racing manufactured hubs. Here is our hub with standard 1/2 inch 20 studs. We have optional 2.5 inch length studs installed that you can buy as a different number. That's
FT6556.
This is a FT6555, and the 3-inch ARPs is a
FT6557.
3-inch ARP studs installed for you to install on your car, or if you order a remanufactured knuckle, you can have us install them for you. Okay, now James is going to take a little bit of the excess grease out from the bore of the bearing, wipe it onto the bearing diameter of the hub, and prepare it for pressing into the knuckle. We're going to use the same socket that we use to push the bearing out of the knuckle, and we're going to use that to support the bearing on the back side as the hub gets pressed in from the other side. This is a 2 5/16 diameter. Okay, as you see, we have the socket supporting the inner race of the bearing on the bottom. The rest of the knuckle is hanging free, and James is going to press the hub into the bearing, inner bearing races of the bearing. We've got a flat metal plate here to support the hub diameter on that hub. And when that thing stops moving, you're going to want to give it one more pump just to make sure you're completely down. And that's it. After this hub is pressed in the knuckle, and you rotate it, check for your rotation, there is going to be some resistance as this hub is being rotated, and that is normal. Oh, these are very tight. There is some preload we have on those two inner races of that bearing right now because of the pressing operation. So your half shaft retaining nut is going to put the final 250 foot-pounds of torque, and that's going to put your final preload on that bearing. So this thing is never going to spin freely. It's always going to spin with a little bit of resistance, and that's normal. Okay, the cross-axis joint goes in with the same tools we removed with. Our 1.5 inch presser and a 2-inch receiver. Make sure this 2-inch is centered to receive the joint as it's pressed in. James will press that joint in. Everything's nice and flat here, so it's going in nice and straight. If you're using the tools with a threaded rod, it's preferred to put a little bit of never seize on there so it doesn't lock up on you. And once you've bottomed out, you're good to go. One more thing here. We're pressing these in with the flange on the front side of the knuckle. This is the front side of the knuckle, this is the back side of the knuckle. So we push them in from the front, and the snap rings are going on the back side of the knuckle. Okay, now we're ready to put the snap rings on the cross-axis joints. And it's going to use an external snap ring pliers. And after you put that on, just give it a little twist to make sure you're in the groove. Second one, just like the first. You hear them pop in, you know you're good to go. Remember, the snap rings go on the back side of the knuckle. Back side is where the caliper bolts are. The front side are where the dust shield screws are. Flanges on the front, snap rings on the back. We have two different options for cross-axis joints. We have their standard joint that has no dust boots on it. And then we also have an optional joint, same exact joint, but we make we put our dust boots in there to protect the joint from the elements in case you're in northern climates. Okay, another very important aspect of knowing whether or not you can reuse your hub is that bearing diameter must be good. Unfortunately, I don't have a really bad bearing diameter here, but you can see how this bearing diameter on the very end starts getting scored. In real severe cases, this is what happens when your nut comes loose and your bearing loses its preload. Actually, you'll see this portion of the hub, the nose of it, become very undersized. In fact, you'll feel a significant step here. This one isn't too bad. This needs to measure 42 millimeters. If it's not 42 millimeters, it's not reusable. Here's the one we just removed. You can see always on the inner race. The outer race is usually always fine. The inner race is where the problem is, and that needs to measure 42 millimeters. If it doesn't, the hub is scrap. Another important thing regarding the hubs is the fitment on the spline. This is a brand new full tilt boogie racing hub, and as you can see, that's where it goes, that's how far it goes on, and that's ideal. If you have a hub that goes on like this, it's garbage. Throw it away. You can see how loose this hub is on here. This hub, there's no nut that will ever hold this hub on this spline. So because this spline is worn out, somebody ran it loose, the nut came loose, the bearing went bad, and then that wore out the spline as they drove a couple thousand miles figuring out what was wrong with their car. So this is garbage, and anything on that reduced diameter is garbage too. So that's a tip on reusing your hubs. Okay, well, we hope that video was informative for you on how you can do your own knuckle rebuilds on your car. The press needs to be a 20-ton at the minimum to do this. If you have like a 10-ton press, you saw how hard that hub came out of the bearing. You might not be able to break that loose with a 10-ton press. So any questions, you can always check out our site. We have all sorts of helpful videos on our site and links to working on the IRS. And any questions, you can inquire at info@fulltiltboogieracing.com. Thank you for watching.